अच्छा चले we're going to start इसी क्वेश्चन से, ठीक है? स्क्रीन थोड़ा सा मैं बड़ा कर देता हूँ. अच्छा, this was the question that we were doing, ठीक है? Let me open the इधर साइड पे कर लेते हैं. अच्छा, this was the question, the last question that we were on. In the question he had stated कि जो molecular ion peak है ना, that it had 3 peaks, 142, 143. And 144. So let me go back to the question. If you can see this question on the screen. So the question was stating that there are 3 peaks, and at the peaks, there were 3 peaks. There were 3 peaks of the molecular ion, and they had a mass of 142, 143, and 144. Remember, 142, 3 different because they're different isotopes, which is why the mass is coming out to be different each time. And then the M+1 ratio is given. So using the M+1 ratio, you can count the number of carbon atoms. वही formula आपने use करना है. The carbon atoms are 100/1.1. ठीक है, and you're going to multiply this by the M+1 height, which is 3.35, divided by the M height, which is given as 43.3. So what is the value that you're getting? How many number of carbon atoms are you getting for this? Saqib, Mariam?
Sir, I'm calculating it.
ठीक है. ठीक है भैया, it's
I'm also
7. ठीक है, so you're getting 7 carbon, ठीक है. And I told you that I mean previously what we were doing was I told you you just always make a bunch of isomers. Previous part actually missing. I just want to say, let me. Previously what we were doing was that we would make a bunch of isomers, based on the information that was provided, and we would then match the isomers with the Nmr spectrum, and that was very easy. But the thing is, when you have 7 carbon atoms, then the molecule is very big, and the number of possible, it's page number 10. 1 second. So the number of possible isomers is a lot. So in this case, I mean, the question is going to be, it has to be done in the same way, but the question, but the question is going to be very tricky. Then he's talking about the M+2 peak. Now the M+2 peak is either because of the isotope of chlorine, because it has 2 masses, either 35 or 37. So jiski wajah se na, there's going to be a difference of 2. Or it could be an isotope of bromine. And bromine has 2 different masses, either 79 or 81. So the mass difference is going to be 2. So he's saying there's an M+2 ratio. And if you look at the ratio very carefully, if you look at the ratio that's given, 43.3 and 4.1. So what इसको अगर मैं बड़ा करके लिखूं, तो 43.3 and 14.1. So the ratio is coming out to be approximately 3:1. And this ratio matches with the ratio of chlorine. Because the chlorine isotopes, their abundance is actually 3:1. So usse wo match kar raha hai. So iska matlab hai there's exactly 1 chlorine. Remember, if there's 1 chlorine, so you're going to either have a mass of M or M+2, depending on which isotope that's being used. And the abundance of 35 is 3 times more compared to 37, which means the abundance of M would be 3 times more compared to the abundance of M+2. अगर bromine होता तो both isotopes have equal probability. तो दोनों की probability exactly same होती है. जितना ये मिलता उतना ही exactly ये मिलता आपको. तो So it's going to be one chlorine. अगर 2 chlorines होता तो 9:6:1 होता, and there would have been an N+4 peak as well. Because both chlorines could be 37 and the mass would change by 4. But there's no second chlorine because there's no N+4 peak. Okay, so far we know that there are 7 carbons and there's 1 Cl. Okay, this is known so far. Uske baad, what you see over here is the Nmr spectrum. And remember, the height or the absorption is the number of hydrogens. So there's 4 hydrogens that are resonating at this frequency. There are 2 hydrogens that are resonating at this frequency, and there's just 1 hydrogen resonating at this frequency. Okay? So you have a total of 7 hydrogens. Okay? And what the Nmr spectrum shows is that there are 3 different chemical environments. So you have 3 different chemical environments. 4 hydrogens are in this environment, 2 are in this environment, and 1 is in this one. So far we've figured out that there's 7 carbon atoms, there's 1 Cl, and there's 7 hydrogens. Lekin, is this equal to 142 or not? Okay, that's the question. That was the molecular ion. That was the mass of the molecule. So if you total this up, and you can try and total this up, it's going to be 7 Cls is 84.
Sir, we get
that-
126.5.
This is going to be either 35 or 37. Okay, remember it had 3 different masses, but there was 143 and there was 144 as well. I'm taking the smallest isotope.
ठीक है, sir.
Here 143 is because of the carbon isotope. Okay, carbon could be 13 as well. I say, anyways, if you take 35, I think you're going to get 126, right? Okay, and 126 means that there's still a difference of 16. So that means you still need to add 16. That means there's an oxygen present as well. So there's probably 1 oxygen present. Okay, Mariam, is this clear?
जी, sir.
I said then what you have is okay, there is 1 oxygen now, so that's the molecule. I said now if you look carefully at this molecule and you have to figure out the structure, and there are 3 different chemical environments that the molecule has to be in. Now, if you look at this molecule, you would notice that you have to figure out how can 4 hydrogens be in the same chemical environment. Okay, so you have to make some guesswork. Okay, if you have a structures present in your mind, then it would be a lot easier to actually figure out what the molecule looks like. And carbon and hydrogen ratio is very low. It's almost 1:1. So the only place where carbon and hydrogen have 1:1 is in a benzene molecule. So there's definitely a structure of benzene because you have 7 carbon atoms. But normally carbon and hydrogen ratio is almost, the number of hydrogen atoms are almost double the number of carbon atoms. But in this case, the number of carbon and hydrogen atoms are almost the same. So that is an indication of a benzene. And the 4 hydrogen atoms, they probably belong to that benzene molecule. Okay, so they're part of that benzene structure. I mean, there has to be a benzene. Otherwise, you can't have such a low ratio of carbon and hydrogen. And the next thing is, so you figure out, that's the first guess that you have to make. You have to figure out that there has to be a benzene in this. Now, the other thing is, once you get to this point that you figure out that there is a benzene, what is left? If you subtract the benzene, then there's 1 carbon atom, 1 Cl atom, 1 oxygen atom, and there's still 2 hydrogens and 1 hydrogen that's still left. So these 2 hydrogens must be a CH2 because there's 1 carbon atom. So there could be a CH2 over here. And there is one Cl and one H also left. You can have an O and H over here, and you could have a Cl over here. Okay, that's one version of the molecule that could exist where these things. So four hydrogens that belong to benzene, two hydrogens in a chemical environment, and there's one hydrogen in a different chemical environment. So that kind of matches your structure. Yeah, ये clear है यहाँ तक? Is this clear? Sakib, is this clear? Ariba, is this clear?
जी सर.
Yes, sir.
अच्छा, नहीं कोई क्वेश्चन नहीं किसी ने पूछा था अभी. अच्छा, but this is not the only arrangement that's possible. You could have a different arrangement as well. For example, you could have a benzene in the middle. Okay, and you could have those four hydrogens over here, and you could have a CH2, and instead the OH is over here, and the Cl is attached to this vacant carbon atom. So that is another possibility. That would still give you something similar to this. Four hydrogens in the same environment, a CH2 that's in a different environment, and an OH that's in a different environment. So you have two options. You can either make it into a phenol, or you could make it into a normal alcohol. Okay, so now a benzene has to be there at all costs. So you have two options, either a phenol or an alcohol. For that, you can now to confirm whether it's a phenol or an alcohol, you can look at the data booklet. And if you look at the data booklet, there's OH somewhere over here. So if you look at the OH, the alcohol OH is between 0.5 and 6. The phenol OH resonates at 4.5 to 7. So you can go and have a look at the peak. Where's the OH peak? This is probably the OH peak. So this is resonating at 2.5. So it's resonating at 2.5 or 2.4. Okay, this single H is definitely OH. So whether it's a phenol OH or whether it's an alcohol OH, you can have a look. It can definitely not be a phenol. Why? Because it's resonating at 2.4. Phenol has a different range, so it must be it's probably a normal alcohol. Probably a normal alcohol. So which is why if you go back and the normal alcohol, which one is the normal alcohol? It's the second one. That's the correct one. Okay, this can't be a phenol. So hence you found your answer. Okay, it's a normal alcohol, CH2, benzene hydrogens, and you have a Cl as well. Okay, is this clear?
Yes, sir.
जी सर.
So Baki, explain your answer. You just
Yes, sir.
okay. Deduce the structure of L, and you can just explain all your reasoning for that. Okay, that there are three different chemical environments, has a mass of 142. You can figure out the oxygen. Probably it's probably a 7 mark. So that's, does the 7 mark include the previous steps? I see the 7 marks include these steps as well. So probably 4 marks. Okay, so you can explain some reasoning and then give the structure. I said this one, suggest one difference in the fragmentation pattern of the mass spectra. Now, what does the mass spectra do? It ionizes the ion and then deflects it. And if there are fragments, the tinier pieces, they get deflected more because they are lighter. So, इस case में, he's saying, okay, what would be the difference in fragmentation pattern of the mass spectra of these two compounds? Difference. So, what is the fragment that can be produced over here in this molecule and that cannot be produced in this molecule? And remember, it's not the structure, it's the mass. The mass spectroscopy only measures the mass. So, what mass particle can exist in the fragment of this molecule that cannot exist in the fragment of this molecule? But as an example, if I if I say I get a fragment during the ionization process, the molecule breaks, and I get a fragment, a tiny fragment of CH2 plus 1, right? And it has a mass of 14. It's equally possible that a fragment could break in this molecule, and you could get a small tiny fragment of CH2 plus 1 over here as well. So you're going to get a mass of 14 over here, and you're going to get a mass of 14, a particle with a mass of 14 over here as well. So, I mean, that's a similarity. Okay, there's a possibility that this fragment could exist in this molecule, and it can also exist in this other molecule as well. Okay, is this part clear?
Ji, sir.
Yes, sir.
अच्छा नहीं वो difference बताओ कि what's the one difference? One difference. They're just asking for one difference. What is the mass, the particle with the mass that can exist over here but not over here? Like 14 can exist both way on both sides. Anyone? Abia, Sara, Mayim, Abu Rera. वो कौन सा particle है जो इसमें exist करे? So it's one second. ठीक है, so 15. Exactly, 15 is the one. Because you can get a particle with a mass of 15, like this can break off, and CST can have a mass of 15. So you'll be getting a particle of 15 over here. But no matter where you break this molecule, you're never going to get a mass of 15. I mean, if you break this molecule, let's say like this, then you would get CH2 14 plus another C would come in, and that would make it 26 plus this one hydrogen. So no matter where you break this molecule, it's never going to give you 15. I mean, there's not going to be a particle that has a mass of 15. So that is one major difference. Okay, 15 well, a fragment that's going to be produced over here, but not over here. That would so it's going to be present over here, but not over here. Is this clear to everyone else?
Yes.
I'd say there's another actually difference. Although this would answer your question, but let me check the marking scheme. There's probably another difference. 1 second. Or maybe there was just this one difference. Just a second. So this was. This was question number. So just let me quickly check. To get it right. No, that's the only one. That's the only one. 15. That's the main difference. And so now the other one is suggest two differences in the Nmr spectra. Now the Nmr spectra depends on the number of or the chemical environments of the hydrogen protons. So forget this. Now focus on the Nmr spectrum. How many different chemical environments are there in cyclopropane? This molecule over here. I mean, if you look at all the hydrogen protons, then they're all exactly the same. That's just one environment. So what's going to happen is they're going to resonate all of them at the same frequency. Just one environment. So there's going to be one peak. That's it. Meanwhile, either there is this these three hydrogens, they have a different environment. This CH2 has a different environment. This CH has a different environment. So there are three different chemical environments, which would indicate that there would be three different peaks. And he's asking for two differences. The second difference is going to be the splitting pattern. There's no splitting over here. So on the other side, there's going to be a lot of splitting. You get three environments, and they're all neighboring hydrogen protons. This peak would be a doublet because the neighboring carbon has one hydrogen. This peak would be a doublet as well because the neighboring carbon has one hydrogen. And this middle one is going to be a multiplet because it has hydrogen protons on both sides. So there's going to be splitting over here, but there's going to be no splitting in this molecule over here. So that's one major difference. अच्छा कोई और क्वेश्चन देख लेते हैं कि this is अच्छा let's try and do this. पिछला clear है सारों को?
जी sir.
अच्छा next one is a sample of liquid P was found on the scene of the crime and was analyzed or the mass spectrum has an M+1. So quickly find the number of carbons. 100 over 1.1 into 0.22 divided by 5.1. Probably 4. Just confirm whether it's 4 carbon atoms or not. As it's 4 carbon atoms, and then you have the M peak is given, that's 88. So 4 carbon atoms having a mass of 88. So the whole molecule is going to have a mass of 88. Now 3 hydrogens in this environment, that's probably a CH3. Not sure, but most likely a CH3. 3 hydrogens in the same environment, that's also a CH3 probably. And this one is probably a CH2. And then you have, and also remember this, 3 hydrogens, that's a CH3 most likely. 2 hydrogens, that's probably a CH2. But if there's 1 hydrogen, that might be an OH. But it depends. Could be an OH, but there's a high probability it would be an OH. And if you have more than 3 hydrogens, that's probably a benzene. Or you could have both CH3s in the same environment. So you're going to get a peak of 6. I said, now use the data to suggest a structure of P explaining your answer. So we're going to look at the splitting pattern. So our guess is that this one is a CH3. But what's next to it? Look at the splitting pattern. Okay, if it's splitting, exactly. What we can also do is, but let's do it the other way around. Okay, I'm going to look at the splitting pattern. Okay, splitting pattern is it's being split into 3. That means its neighbor is CH2, or the neighbor has 2 hydrogens. Okay, because it's a triplet peak. I said this one is a singlet peak. That means neighbor has no hydrogen. So the neighbor could be OH. It could be something that is not causing splitting. Has no hydrogen. And this one is a quadruplet peak. That probably indicates that the neighbor is CH3. I said now, based on this, what we are getting is okay, there's a CH3 next to a CH2, and we're also getting that there's a CH2 next to a CH3. So that pretty much indicates that the CH3 and CH2 are together. Okay, one of the peak is suggesting that there's a CH3, and next door there's a CH2, and the other peak over here is suggesting that there's a CH2 and the neighbor is CH3. So they're probably next to each other, and that's one thing. And then there's the CH3 that has nothing attached to it. Okay, so there's this CH3 that's a singlet. And there is a 4th carbon atom. So I'm not sure where the 4th carbon atom is at the moment. This one is a triplet. This one over here is a quadruplet. So the middle part is at the moment missing. We're not sure what that is. So I'm going to come back to the MR now, and I'm going to come back to the MR. So far, what's missing is the question mark is that I have 1 carbon because there are 4 carbon atoms. So that indicates that there's a carbon atom missing in the middle. That's not showing up over here. So that means the carbon atom has no hydrogen at all. So that's 4 carbon atoms. If you remove 4 carbon atoms from this 4, 12 4s are 48. That leaves you with how much? 40. And if you remove the hydrogens, there are 8 of them. That leaves you with 32. So we're short of 32. 32 is most likely 2 oxygens. Okay, but again, we're not sure. So there's this middle part that's still missing. And this middle part has 1 carbon and probably 2 oxygens. So I'm now going to open the data booklet and I'm going to see okay, what is this CH3 next to. I mean, if it's resonating at 1, if you look at the data booklet, so when does CH3 resonate close to 1? So that's probably when it's next to a CH2. Okay, so or alkane, that's the environment. So that makes perfect sense. So this first one is probably this one, the one that's part of the carbon chain. I said let's focus on the CH2. This CH2 is resonating at 4. Okay, somewhere around 4. So I mean, it is this CH2. There's only one CH2. So what's next to it if it's resonating at 4? So open the data booklet and you would notice that CH2 next to serial bond O resonates at 2.2. So that's out of the question. CH2 next to O is the one that resonates around 4. So that means okay, if we go back, तो यहाँ पे ना ये जो question mark है, that's this CH2 is probably next to an oxygen. Okay, so we're done with this. We know okay if it's resonating at 4, and we were suspecting that there are 2 oxygens, so we got 1 oxygen included. Now the final thing is, what is this CH3 next to? The singlet. Okay, the one that had no hydrogens next door. So it's resonating at 2. So open the data booklet and at 2, you have 2 options. It's these 2 options. Close to 2. So it's either next to serial bond O or it's next to aromatic ring. It's not a benzene because we don't even have 6 carbon atoms, so that's out of the question. So it's probably a serial bond O. So the final one is going to be that there is a C double bond O over here, and this is most likely an ester. Okay, so that's the molecule, and it agrees with all the information that's given over here. ठीक है, ये clear है? Sara, is this clear? Mariam? Abu Rera, Saqib?
Clear, sir. All good.
Yes, sir.
अच्छा चलो ठीक है. So I'm just going to try and open some 2020 का देख लेते हैं NMR के questions just because these are probably slightly old जो worksheet में. So NMR nuclear. टू वन में क्यों आ रहा है? Just 1 second. NMR लिख लेते हैं.
सर ये एग्जामिनर रिपोर्ट क्या होती है सर?
कुछ नहीं होती, मार्क्स की नहीं होती है. अच्छा ये किसमें क्वेश्चन दिया हुआ है? Just 1 second. It's 24/3. Just 1 second. तो इसके अंदर देख लेते हैं कि NMR एक सेकंड स्लो क्यों हो गया. अच्छा, so there's this, ये वाला कर लेते हैं. ठीक है, show your working mass to charge mass spectroscopy. So this is बस ठीक है, let's do this one. और proton NMR के ऊपर है, ठीक है. So this one is May June 19, ठीक है, 4-1. Now the question says, तो पहले तो जल्दी से वो सारा कर लेते हैं कि tell me the number of carbon atoms in this. कि it's उसने सब कुछ वैसे दे दिया, C5H10 O2, ठीक है. So the peak heights mm+1 ratio. So to show that there are 5 carbon atoms, you can show that. That's, you just have to prove. उससे पहले दे दिया C5 carbon atoms. Forget that. Formula लगाना, you'll get this. The mass spectrum has a peak at mass to charge 57. Complete the equation to show the fragmentation of X to produce this peak. तो उससे क्या है, there's this unknown compound, लेकिन वो कह रहा है कि the mass, उसका जो fragment है that's 57. अब मुझे बताओ कि what combination would make 57? Like इसके अंदर से कौन सा piece टूटा होगा which would have broken away that would give you 57. So for 57 I'm assuming कि, और इसके बारे में कुछ भी नहीं बताया हुआ कि it's neither an ester or carboxylic acid. No information is given. So 57, that's if you take 3 carbon atoms, and remember it has to be a sensible structure. So we can think of 3 carbon atoms, that's 36. If I put an oxygen over there, so what is 36 plus 16? That's 52. So 52, and I can add 5 hydrogens, I guess, right? So can somebody confirm whether this is going to be 57 or not? Okay, 36 plus 16, that's 52, I think. And then 53, 54, 55, 56, and 57. So I'm going to write, okay, you might get a fragment with 3 carbon atoms and 5 hydrogen atoms, and it's going to contain 1 oxygen. Okay, that's 1 fragment. And the other piece that would be broken away is, okay, subtract this, so that's that leaves you with 2 carbon atoms, and that leaves you with 5 hydrogen atoms, and there's still an oxygen over there as well. Okay, that's the remaining piece. So this over here is 57. ठीक है, ये clear है? Ariba, Sara, Mayim, Saqib, is this clear?
जी सर.
Yes, sir.
अच्छा, then
Yes, sir. Clear, sir.
अच्छा, then he's saying कि say the use of TMS and CDCLC in NMR spectroscopy. Now what is TMS and what is CDCL3? Okay, TMS, remember TMS, that's tetramethylsilane. उसका थोड़ा सा ना मैं बता देता हूँ कि TMS is tetramethylsilane, which is silicon with the CH3s. 4 of them. अच्छा, that's usually the solvent. ठीक है, that's usually the solvent that is used. कि आप किसी की भी NMR spectroscopy कर रहे हो ना, तो this is used as a reference. क्योंकि इसके अंदर ना there are 12 hydrogens in the same environment. यानी it's going to be a single peak, single resonant frequency. तो जब आप अपना ग्राफ देख रहे होगे ना NMR spectrum का, तो imagine the whole solvent is actually TMS. उसके अंदर बस थोड़े से molecules added है. So the solvent is going to give a very, very strong peak, and it's going to be a single unique peak. That's your TMS peak. ठीक है, तो एकदम से ना आपकी स्क्रीन के ऊपर you'll get this TMS peak. और वो बीच में ना छोटे-छोटे molecules होंगे, जो भी है. Let's say there's a CH4 molecule, आप उसकी NMR spectroscopy कर रहे हो. Now the solvent is everywhere. Like if there are 1,000 molecules of the solvent, there are probably just a few molecules of CH4. तो फिर वो जो CH4 के जो हाइड्रोजन होंगे ना, उनकी पीक आ रही होगी कि जी 4 हाइड्रोजन की पीक यहाँ पे आ रही है. तो chemical shift is basically the difference between the TMS peak and the TMS is your reference point. ठीक है, तो आपको पता लगता है अच्छा ये frequency ना यहाँ पे resonate कर रही है. So TMS is used as a reference. ठीक है, is this clear? And it's used as a solvent. ये clear है सारों को?
जी सर.
Yes.
अच्छा,
Yes, sir.
अच्छा, on the other hand, The problem with TMS is कि TMS is showing up. तो उसका मसला ये हो सकता है कि it might cause interference, it might mix up with जिसकी आप NMR spectroscopy कह रहे हो कि ये इतनी strong आ रही हो कि आपको वो नजर ही ना आ रहा हो, ठीक है? So that's a possibility as well. So sometimes what you do is कि you use deuterated solvents. अच्छा, deuterated solvents like CdCl3, they don't have a hydrogen, so they're not going to cause any resonance. तो मतलब जब आप NMR spectrum करोगे ना तो मतलब the solvent is not going to be your headache because no resonance would be caused because of this. ठीक है, so that's a deuterated solvent. You either use a deuterated solvent which doesn't have a hydrogen ताकि solvent जो है ना जिसके अंदर आपने molecule को mix किया हुआ है वो resonate ना करे, or you could use TMS. ठीक है, TMS का फायदा ये है कि वो एकदम से बड़ी सी TMS की पीक नजर आएगी तो आप फिर उससे ना केमिकल शिफ्ट देखोगे कि आपके जो मॉलिक्यूल्स के जो हाइड्रोजन है ना वे आर दे रेजोनेटिंग. अच्छा, बट सो दैट्स द बेसिक आइडिया. अब मैं बस इसको चेक कर लूं बिकॉज़ इट्स अ 0.5 मार्क दिया है. मतलब ये दोनों चीजें ना बिल्कुल इंपॉर्टेंट नहीं है, ठीक है, लेकिन उसे वन लाइन के अंदर लिखने को क्या कहा हुआ है. जस्ट लेट मी इसको हम जल्दी से चेक कर लें कि ये खाली एक लाइन में उसने एग्जैक्टली व्हाट इज ही आस्किंग फॉर. ठीक है, जस्ट अच्छा ये कौन सा क्वेश्चन हमारा. दिस वाज क्वेश्चन नंबर 8. ये 0.5 मार्क्स में इतनी थोड़ी लाइन में क्या उसने एग्जैक्टली मांगा हुआ है फॉर क्वेश्चन 8. ठीक है, वो कह रहे दिस इज अच्छा बस वो कह रहे दिस इज यूज्ड एज अ रेफरेंस, दिस इज यूज्ड एज अ सॉल्वेंट. ठीक है, दैट्स इट. तो टीएमएस इज यूज्ड एज अ रेफरेंस क्योंकि वो रेफरेंस चाहिए. तो बस वो एक लाइन ये लिखी हुई है उसने. अच्छा, एनीवेज, coming back to the question, where's the question? Where did our question go? अच्छा ये. Now the proton NMR spectrum is given. So that's C5H10O2 and you're given well, I mean clearly there are 4 environments, right? Or बस थोड़ा सा वर्किंग करो, आसान हो जाएगा. एक सेकंड. अच्छा चलिए ये कर लेते हैं जल्दी से कि मैंने थोड़ा बहुत तो सॉल्व कर लिया था कि by looking at the NMR spectrum this is CH3 this is CH3 most likely CH2 neighborhood भी देख लिया था कि triplet peak है तो the neighbor is CH2 singlet है तो neighbor has nothing ठीक है it doesn't have a hydrogen the quadruplet peak so that's the neighbor is CH3 and then you have a singlet that means neighbor has nothing ठीक है and then we figured out KG it's resonating at around both of them are resonating around 3.5 to 4. So I opened the data booklet and when I did that I found out KG 3 to 4 के बीच में ना resonance है ना that's basically next to O. तो इसका मतलब ये कि this CH2 and this CH2 are both next to oxygen. How is that possible? It's probably possible that there is CH2 और फिर बीच में एक ऑक्सीजन पड़ा हुआ है फिर बीच में there's another CH2, right? So I mean that's how both CH2s could end up with the in this configuration next to O, right? फिर ये देखा था कि this is around 2.2 and we figured out from the data booklet that this is probably CH3 next to C double bond O. So which is why it's also a singlet because the neighbor has no hydrogen. And then you have this CH3. अब बाकी molecule draw करना that's kind of easy. कि यहाँ तक क्लियर है सारों को? अबूरा क्लियर है? अरीबा, मरियम, सारा, is this clear?
Yes. Yes, sir.
ठीक है. Now remember both of these are CH2s and both of these have this configuration. So I'm going to start from that point. It has this thing CH2 इस तरह करके ठीक है. Now one of the CH2 is a quadruplet. That means the neighbor is CH3. So one of the CH2s has a neighbor that is CH3. Right? And that's probably this one. But ये जो CH3 है ना that's probably this one. क्योंकि this CH3 had a neighbor which was CH2. तो दोनों आपस में neighbors हैं एक दूसरे के ठीक है. So that is probably this one. तो ये भी हो गया. तो मैंने ये मिला दिया. ये दोनों बीच में आ गए ठीक है. So you're left with CH3 C double bond O. So that's the only thing that's missing. तो ये तो वैसे ही end पे है. So it's probably CH3 next to C double bond O. And that pretty much sums up your molecule because this molecule is exactly matching this. This CH2 is not going to split. So that's this one over here. This CH2 is going to be a quadruplet peak, so that's there. This CH3 is going to be a triplet peak, so that's there. और बाकी ये CH3 रह गया और CH2. So deduce the part of the molecule so you can do all of this. अच्छा उसने part ही क्या है? I think he's not asking for the whole molecule. Actually he is asking for the whole molecule क्योंकि now मतलब उसने पहले parts पूछे हैं ठीक है वो आप mention कर लो अपने working कर लिए. But then he's asking it's reacting with iodoform. It gives an iodoform test. So that also makes sense. कि iodoform test किसका होता था? Iodoform test होता था कि जब you had a CH3 and a C double bond O, a methyl ketone. तो ये CH3 टूट के ना अलग हो जाता था iodoform test में and it would form a CHI3 yellow precipitate. और जो बाकी होता था ना molecule यहाँ से वो carboxylic acid बन जाता था. To suggest the structure for X, so we've pretty much done our job. What we just need to do is we need to look at the marking scheme and see if we drew the correct structure, which looks fine. Okay, CH3, C double bond O, CH2, then there's another O, then CH2, then CH3. So this is exactly what we drew. तो ये वही है. ठीक है, ये clear है सारों को?
Yes, sir. जी.
तो ऐसा तो remember the key is तीन चीजें. Environment, पहले तो वो mass spectroscopy की 2-3 चीजें आ जाएंगी. Number of carbon atoms पता लग जाएंगे, Cl, Br का पता लग जाएगा. I'll just sum this up. Environments. How many environments do you have? What's the splitting pattern? कि साथ वाला neighbor कौन सा है, ठीक है? और फिर data booklet open करो, देखो कि मतलब ये जो CH2 पता लग गया था, but we figured out कि CH2 next to O. ये पता लग गया था, we figured out CH3 next to C double bond O. तो फिर आप थोड़ी सी डिटेल वगैरह फिगर आउट कर लो उसके बाद। चलो ठीक है, लेट्स कंटिन्यू टुमारो। आई विल सेंड यू न्यू टाइमिंग्स नाउ, ठीक है, क्योंकि अब शाम वाली टाइमिंग्स जो है वो दे नॉट गोइंग टू वर्क, मगरिब और तरावी। सो रमजान मुबारक सारों को, ठीक है। सऊदी अरबिया में तो मेरे ख्याल से आप लोग, तो I'll send you new timings, ठीक है।
Sure, sir.
ठीक है सर।
मुझे बता देना, even whatever works, ठीक है, probably around the afternoon, ठीक है।
Okay, sir. Afternoon. That's good.
Okay, take care.
Allah Hafiz, sir.
ओके।